Hi there, welcome to my new course YOLO Custom Object Detection Quick Starter with Python. This is the fourth course from my computer vision series. As you know, object detection is the most used applications of computer vision, in which the computer will be able to recognize and classify objects inside an image. In this course, we will be specifically focusing on YOLO, which means you only look once, which is an effective real-time object detection recognition algorithm which is featured in .NET, an open source neural network framework. This course is equally divided into two halves. The first half will deal with object recognition using predefined dataset called as a Coco dataset, which can classify around 80 categories of objects, and in the second half we will try to create our own custom dataset and train the YOLO model. We will try to create our own coronavirus detection model. And let's now see the list of interesting topics that are included in this course. At first, we will have an introductory theory session about the YOLO object detection system. After that, we are ready to proceed with preparing our computer for Python coding by downloading and installing the Anaconda package, and once done we will check and see if everything is installed fine. And I know most of you may not be coming from a Python based programming background. The next few sessions and examples will help you get the basic Python programming skill to proceed with the sessions included in this course. The topics include Python assignment, flow control, functions and data structures. And then we will install OpenCV, which is an open source computer vision library in Python. And after completing all these things, we will have an introduction to convolutional neural networks, or the CNN, its working, and also the different steps involved in a convolutional neural network. And now we can proceed with the part 1 of this course, which involves object detection and recognition using YOLO pre-trained model. We will have an overview about the YOLO model in the next session, and then we will implement YOLO object detection from a single image. Often after the detection, YOLO will give back more than one successful detection for a single object in an image, and this can be easily fixed using a technique called NMS, or non-maxima suppression. We will implement NMS in our next session, and using that code, the NMS implemented code as our base, we will try the YOLO model for object detection from a real-time webcam video, and we will check the performance. Later we will use it for object recognition from a pre-saved video file from our computer. And that's all in the part 1 of our course. And now we can proceed with the interesting part 2 of our course, in which we will attempt to train a .NET YOLO model, a model that can detect coronavirus from an electron microscope image or video output. And before we go ahead with the implementation of the custom model, we will discuss the pros and cons of using a pre-trained plug-and-play dataset model and also a custom dataset trained model. Also, we will have a quick discussion about the free GPU offered by the Google Colab and also its features. And in the coming session, we will start with phase 1 of our custom model, in which we will do the preparation steps to implement the custom model. We will at first download the .NET source from GitHub and we will prepare it. We will then download the weights file required for both the testing and training, and then we will edit the required configuration files to make it ready for our custom coronavirus detector. And in our second phase for our custom model, we will start collecting the required data to train the model. We will collect all the coronavirus images from internet as much as we could and organize them into folders. Then we will label or annotate the coronavirus object inside these images using an open source annotation tool called label img. And after that we will split the gathered data set, 80% for training and 20% for testing. And finally, we will edit and prepare the files specifying the location of training and testing dataset in our folder. Now that we have all our files ready, in our third phase we will zip and upload them into the Google Drive. After that, we will create a Google Colab notebook and configure the Colab runtime to use the fast, powerful and free GPU service provided by Google. Then we will mount our Google Drive to our Google Colab runtime and unzip the darknet zip folder that we uploaded. Our Colab runtime is actually a small Ubuntu computer, and we have to convert the encoding of all the editable files from Windows DOS to Unix as our next step. Then we will compile the darknet framework source code and proceed with testing the darknet framework with a sample image as our fourth phase. The free GPU based runtime provided by Google Colab is actually volatile, which means it's not permanent. It will get reset every 12 hours, or maybe sometime we lose our internet connection. So we need to save our weights periodically during the training to our Google Drive, which is actually the permanent storage. In our phase 5, we will link a backup folder in the Google Drive to the volatile Colab runtime. And finally, in our phase 6, we are ready to proceed with the training with our own coronavirus model. We will keep on monitoring the loss for every iteration or epoch. Our model will automatically save the weights every 100th epoch securely to our Google Drive backup folder. And if everything is working correctly, we can see a continuous decrease in the loss values as we go through each and every epoch. And after many number of training iterations, our model will come to a convergence, or it will flatline. In that state, there will not be any further improvement or decrease in the loss. At that time, we will come to know that our training can be stopped, and finally we will get a weight which have the least amount of loss. And later we will use that weight file in our previously done object detection exercises to do a prediction for an image that contains coronavirus object in it. We can see that our model clearly detects objects. We will even try this with a video file and see how it performs. That's all about the custom object detection. We cannot claim that this is a fully fledged, flawless, production ready coronavirus model. There is still room for improvement for our model. But anyway, by building this custom model, we came all the way through the steps and process of making a custom YOLO model, which will of course be a great and valuable experience for you. And then later in a quick session, we will also discuss few other case studies in which we can implement a custom trained YOLO model. We will also discuss the changes we may need to make for training those kind of models. And that's all about the topics which are currently included in this quick course. The course images and the weights that we used in this course has been uploaded and shared in a Google Drive folder. I will include the link to download them in the last session or the resource section of this course. You are free to use this code in your projects with no questions asked. Also, after completing this course, you will be provided with a course completion certificate which will add value to our portfolio. So that's all for now. See you soon in the classroom. Happy learning and have a great time.